Okay, so here's part B. So let's return to our original problem now that we've. Does this Tower of Powers remind you of anything?
Well, I think we did Towers of Powers in Graham's number.
Yeah, it was 3, I think.
Yeah.
3 to the 3 to the 3 to the 3.
Right, we didn't go all the way to infinity.
No.
We went pretty close though.
Yeah, it seemed like we got pretty close. Okay. Oh, sorry, 309b. So we're getting to this infinite tower of x's. Powers of x is equals 2. How are we going to figure out what x is?
Well, if x is 1, then this equals 1. If x is 2, then it equals infinity.
Yeah.
So we think that x is going to be pretty close to 1.
Probably.
Okay. All right, so we can make some estimate that x is going to be pretty close to 1.
Well, we need it to be 2. Well, we could start with 1.5.
Okay. And what would you do there with 1.5?
Well, you'd have to do 1.5 squared. 1.5 times 1.5.
And just keep
Do
going,
that.
doing powers of 1.5. Okay.
That's a little hard.
Yeah, but I mean, that would be a way we could do it on like a computer or calculator. We could try guessing. But are there any math ideas we could use here?
Well,
We could make a simpler problem.
Interesting.
Like we could say x to the x.
Equals 2?
Yeah, and then x to the x to the x, but x would keep changing.
Yeah. I'm not sure that's simpler, but yeah, looking for a simpler idea inside of this problem is not a bad one.
Well, we could use the 1. Well, we found 1 plus a half plus a fourth plus an eighth. Doing that all the way to infinity added up to 2.
Ah, that's an interesting thing to remember. That 1 plus a half plus a fourth, that equals 2. So we have seen an infinite series that equals 2. Here we have sort of an infinite tower of powers.
We're multiplying here.
Yeah.
I think a half times a fourth times an eighth. That isn't equal to 2.
Why not?
Well, you're getting really small.
Yeah, you'd be getting really
like
small.
Like an eighth of a fourth.
Right.
Well, and x has to stay the same.
Okay.
So, but you can't really try values for x.
Yeah, that's what makes this problem interesting, is it's difficult to try values for x. So we have to have some other idea here.
Well, what ideas could come into play here?
If it's the decimals are hard to calculate. You can't really calculate it out.
Right, it would be very difficult to calculate this out.
So there must be some easy way to do it.
Hopefully there is an easy way to do it. So the question here is, what's the only thing we know here in this problem?
We only know that this infinite power of x's equals 2.
Okay.
What if we can find another equation that x equals something?
All right. Yeah.
Well, what does x to the x equal?
X to the x equals, what would, I don't know.
If this is 2, then what's that? Well, that's really an entirely different question.
Yeah, it is.
How can we simplify these powers?
Yeah, that's a great question. We gotta find a way to try to simplify this. All right, let's move on to part C.
Okay.